Welcome to the second day of graphing quadratic function. Today, we're going to learn how to graph quadratic function from a word problem. Yesterday, we just learned how to graph equations. Today, we're going to look at how this plays into the real life or real world. So let's just start by reading the word problem here, the real world application. So the height in feet of a soccer ball that is kicked by Fesa can be modeled by the function f of x is equal to negative x squared plus 64x, where x is the time in seconds after it is kicked. Find the soccer ball's maximum height and the time it takes the soccer ball to reach this height. Then find how long the soccer ball is in the air. Alright, step number one, what you want to do first is you want to make sure you understand the problem. One thing I like to do is to draw a picture. So instead of drawing a picture, I just copy and paste a picture to the right over here. So this word problem is talking about Fesa kicking a soccer ball. So he kicks a soccer ball. You know, when you kick it, it's going to go up some height, and then it's going to come back down all the way down to the ground. After you draw a picture, you want to ask yourself this question. What is the question? What is the word problem asking you to find? In this case, it is asking us to find the soccer ball's maximum height. So I'm going to write that down. Maximum height. The time it takes a soccer ball to reach this height. So time to reach max height. And lastly, how long would the soccer ball be in the air? So how long will the ball be in the air? We're basically telling you how the time the soccer ball goes all the way up and comes all the way down. That's what they're talking about. So after you find what the question's asking you, step 2, you want to make a plan. You want to ask yourself, how do I find these parts from step 1? How do I find the maximum height? What do I need to do? What do I need to do to find the time this ball reaches the maximum height? And how do I find how long will the ball be in the air? So let's go back and look at the graph on the right, the picture on the right for just a minute. So I'm going to trace how the ball is flowing through the air. It goes all the way up, eventually come all the way back down. And I'm going to label the x-axis. Let's say we're talking seconds. How many seconds does this ball go up and then come back down on the x-axis? And then on the y-axis, let's say that is your height. And that's in feet. So we know that when he kicks a soccer ball, it goes up, 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 and then if it's right at this point here, this is the highest point. And our highest point is the y. And we know that at the highest point, we talked about that point is called the vertex. So I'm going to put a dot here, and that is going to be a vertex. And remember, a vertex has a x value and a y value. But for this question, how high is the maximum height? You only want the y value. You want to find the vertex first and just tell me the y value, because the y value represents the height. The x value only represents seconds. So let's go back to step number 2. Let's say that to find the maximum height, you need to find the y value from vertex. And the time at the maximum height, we just said the maximum height was at the vertex. The y value represents the height, and the x value represents the second. How long this will, how long will this take to get to the maximum height? So that will be the x value from the vertex. Last piece. How long until the soccer ball hits the ground? So this question is asking us about time. So we start here and we kick the ball. How long will it take until it hits the ground over here? So when it hits the ground, we know that this point right here, when it hits the ground, this is the x-intercept. And the x-intercept has a x and a y value, but we talked about that the x-intercept, the y value will always be 0. But if you also notice, there's also an x-intercept on the left over here as well too. But when you find it, you want to find the x-intercept, the bigger x-intercept, because you don't want to find the smaller one, because when you kick the ball, it's going to be a certain amount of time farther away from where you kicked it. So you want to find whatever the x-intercept is. If you have 2, you want to pick the biggest one. So to find time soccer ball hits the ground, you want to find the x-intercept. Alright, after you make a plan, let's start figuring all of these information out. So if you go to step number 3, we're going to do what we did yesterday and the day before that. We're going to find the axis of symmetry first. So find the axis of symmetry. And remember, the axis of symmetry's equation is x is equal to negative b over 2a. Alright, so if we're to go back up to our equation, our b value is positive 64, and our a value is negative 16. So a is equal to negative 16, b is equal to positive 64. So we have x is equal to negative b, and the b is positive 64, over 2 times a. 2 times a, and a is a negative 16. So if we were to simplify this, we'll get negative 64 over negative 32. And as you can see, we have a negative in the top and a negative in the bottom. That will cancel to be a positive. And 64 divided by 32 just gives us a positive 2. So our axis of symmetry will be at x equals to 2. Step number 2, you want to find the vertex. So let's find the vertex. And to do so, we are going to substitute the x from our axis of symmetry into our equation. So our equation was y is equal to negative 16 x squared plus 64x. So everywhere I see an x, I'm going to plug in this 2 in for the x. So let's write that out. Y is equal to negative 16 x, but instead of the x, I'm going to write positive 2 squared plus 64 x instead of the x, I'm going to write a 2. So if we were to simplify this, 2 squares 4, and 4 times 16 is a negative 64. So y is equal to negative 64 plus 64 times 2 gives us 128. And if we were to solve that, we would get a positive 64. So our vertex is at the point 2, 64. Our x and our y. After we find the vertex, let's find the y-intercept. So to find the y-intercept, all you do is substitute the x to be 0, because we know that when the graph hits the y-intercept, the x value will be 0. So again, our equation was y is equal to negative 16x squared plus 64x. And everywhere I see an x, I am going to substitute 0 in for the x. So y is equal to negative 16 times 0 plus 0 squared, 64 times 0. And then we know that 0 squared is 0, 0 times 16 is 0, 64 times 0 is 0, so 0 plus 0 is 0. So our y-intercept will be at the point x equals to 0 and y equals to 0. So our y and our x. Alright, next step, we're going to find our x-intercept. And in this case, we're not going to use a box method. I made a mistake here. Since there is no c term in our quadratic function, we are going to be using the GCF method. As you can see, our equation was y is equal to negative 16x squared plus 64x. We don't have our c. Our c will be 0, which will not work for the box method. So we'll use the greatest common factor method that we learned a few days ago. Okay, so again, how the greatest common factor will work is you look at your term, negative 16x squared and 64x squared, and you ask yourself, what is the greatest common factor that these two terms have? Remember last time we prime factorize both of the term, and then we found the greatest common factor. You can do that, but I'm just going to show you a quicker way to do it by just looking at the terms. So I'm going to cover the variables up first. And ask yourself, what can go into 16 evenly, or what can divide from 16 evenly and from 64 evenly? There's many numbers, like 2 can go into 16 and 2 can go into 64 as well too. But that's not the biggest number. That's not the greatest common factor that they have in common. You can keep on going, and you'll eventually find that you can take a 16 out of 16, and you can take a 64 out of 16 as well too. So let's take a 16 out of both of these. So I will write down y is equal to 16. And then I'm going to remove my box and cover up my numbers. Now I'm going to ask myself, what does a variable have in common? The first term has an x squared. The second term just have 1x. So the thing they have in common is just 1 of the x. So I'm going to pull 1 of the x out. Alright, so I'm going to remove these boxes. And then put a parenthesis. So if we were to take 16 out of 16, a negative 16x, 16 out of negative 16, we will be left with just a negative 1. If we were to take an x out of x squared, we would just be left with 1 of the x. Plus, if we were to take 16 out of 64, we'll just be left with a 4. And we took 1 of the x out of this x. That means we don't have any more x to be with the 4 here. So after factoring the greatest common factor out, this will be what we have as a factor form for the polynomial. So remember we said that when we're finding the x-intercept, the y's are always going to be 0. So I'm going to set y to be 0. So 0 is going to equal to 16x times negative 1x plus 4. Alright, so to solve this, we're going to do what we did like yesterday. We want to know where this 16x equals to 0 and where this term inside here equals to 0. So I'm going to do 16x equals to 0 and negative 1x plus 4 equals to 0. So to find when the left term here equals to 0, I'm going to divide it by 16 on both sides. That's the left side is going to cancel, and x is going to equal to 0. So one of our x-intercept is at x equals 0. And on the right side, I am going to subtract 4 on both sides. And then we're left with a negative 1x is equal to negative 4. Then I'm going to divide both sides by negative 1 to get rid of the negatives. That cancels. And we're left with x is equal to a positive 4. So as you can see, one of our x-intercept is at 0, and our other x-intercept is at positive 4. So let's scroll up and plot these points. So let's start with our vertex, and our vertex is at step number 2. And we said our vertex was at 264. So you go over 2 and over 2 and all the way up to 64. So a point right here. The next point we found was the y-intercept. The y-intercept was at 0, 0. So I'm going to draw a point at 0, 0 right here. Lastly, we just found that our x-intercept is at x equals 0 and x equals to 4. So x equals 0 is also right here. X equals to 4 is all the way down over here. Alright, so let's go ahead and connect the graph with a smooth curve. So this would be our graph for, let's undo this, for Fesa kicking the soccer ball all the way up to 64 and comes all the way back down on the ground. So again, our vertex, which is 264, and we say our x was our time in second, and our y was in feet. Our height in feet. So to answer the first question, what is the maximum height? So the maximum height here would be 64. So 64 is the maximum height. So max height equals to 64 feet. The next question asks us to find the time of the maximum height. So as you can see, the maximum height is at 64, and the time it got there was in 2 seconds. So time at maximum height height equals to 2 seconds. And the last question asks us, when will the soccer ball hit the ground? So as you can see, you start kicking the ball, you kick, and then it comes all the way down right here. This is where it hits the ground. It hits the ground at the point 4, 0. And we know that they're talking about time because they're asking about how long will the ball until the ball hits the ground. And it will hit the ground at 4 seconds. So ball hit ground at 4 seconds. Alright, so I hope that helped you understand why we use quadratic function to model real life application. And I hope that by doing these steps over and over helps you understand how to find the axis of symmetry, how to use that to find the vertex, and how to find the y-intercept, and how to find the x-intercept. Again, if you have any question, let me know during work time and I can help you out. Thank you. Bye-bye.